Welcome back to another video in this series. Firstly, I apologize for such a delay. I was traveling recently, but now I'm all good. And yes, here I have another video from the series. And as you can see from the title already, this time we'll be dealing with negative and fractional indices. So it could be anything like a term which has these kind of power, or maybe a term which has this kind of power, right? So that is all that we'll be dealing with. So first I'll briefly introduce you to these kind of laws and how to deal with them, and then we'll practice 4 examples which are going to help you strengthen this topic even more. So yeah, let's begin. What you can see is that I've written 4 distinct laws over here. These 4 laws explain the 4 different kind of conditions that will be given to you, based on which you have to solve the indice basically, or you have to simplify those terms, right? So in the first one that I have over here, this says that what if a constant a is raised to a power of 1 over m, where m is again a real constant. So I'll show that with an example. So let's take 3 raised to 1/5, right? Here, as you can recognize, a is 3 and m is 5. So what this basically means is that I can write this in the form, first I'll just put a root on 3, and then whatever power I have in the denominator, that is basically the root of it. I don't know how to say that, like the square root, cube root, then there is the 4th root, and here in this case it is the 5th root. Okay, so you can also put that in the calculator. I understand you have never seen this before, but yes, you can put these kind of things in your calculator and you can easily get your answer. If you look on the second example, again you have a constant a, but this time it is again raised to a fraction, but neither the numerator nor the denominator is 1. So what does that mean? So basically, I'll show this with an example again. Let's say we have 5 raised to the power of 7 over 2, right? Always remember, whatever you have here in the denominator, okay, this is always going to come outside the root. First thing, if you have anything fractional, if there's any fractional power, that will literally mean that you have to put a square root. I mean, not a square root, you need to put a root, okay? So I'll just start by putting a root. Again, I'll put 5 over here. Now, like I said, whatever we have here in the denominator, this is always going to come outside the root, right? Whatever now you have in the numerator is going to come inside the root. I want you to focus on this actually, and do not confuse or mix it, otherwise you're going to get the whole answer wrong. Whatever you have in the denominator is going to come outside the root. You can also see that in the above example. Whatever I have in the denominator goes outside the root. Whatever is there in the numerator will always come inside the root thing. Okay? Yes. You can also get a better idea. I'll basically show you some example questions, and yeah, that's when things will get a bit better. In the third law, what we can see is that here we have a normal constant a, but this time is raised to a negative power. So what does that mean? So basically, I'll take an example. Let's say we have 2 raised to the -4th. Now in this case, in case of indices and these kind of things, when you have a negative power, that basically means you are applying the constant power, the power whatever that's represented by the constant, but to the reciprocal of the number. That means 2 raised to -4 is literally the same as 1 over 2 raised to the 4th power. Okay, you're gonna get that once you practice more questions. And then the last one is something that I think all of us know from our GCSEs, that anything, it could be anything raised to the 0th power is going to be 1. But okay, there's an exception. 0 raised to the 0th power is undefined. Yep, I did ask that question once in my classroom, and my teacher said that it was undefined. So that's an exception, but otherwise anything else, if it is raised to the power of 0, it is always going to be equal to 1. I have the first example for you. So as you can see in this example, we have x cubed over x raised to minus 3. So we don't have to panic. We'll just start by simplifying this further. So I'll write x cubed as it is. Now we just saw that anything raised to the minus power basically means that I'm applying the same power but to the reciprocal of it. So x raised to minus 3 basically means 1 over x raised to 3, right? I'll just write that down over here. So x cubed over 1 over x cubed. Now I can simplify this further. This becomes x cubed times x cubed over 1. And from the very first video, we can recall that this will basically add up and we get x raised to the 6th power. And yeah, that's the final answer. Second example that I have, what we can see is that here two terms are first being divided and then we have some negative powers. So we'll just go step by step. So I'll start by writing 2x raised to the 1.5 divided by 4x raised to the minus 0.25. Now what I can do is, my first focus will be to see if I can, in any way possible, simplify the fraction that I have already. But I'm only here talking about these numeric values, so I can definitely simplify this further. So what I have is then 1 by 2 x to the 1.5, and here I have x raised to the minus 0.25. Now what I also could do is that I could definitely use my second law, where I have a negative power. I can just reciprocal the 2 part and I can write that again. But a better way of doing that would be is to basically see here that we have x terms here. That means we have the same base, but then we have 2 powers. And from our very first video, we know that if we have a same base and if then 2 powers are right there but then they're dividing, what we can do is that we can basically subtract the powers together. So it will be 1.5 minus of 0.25, right? If I simplify this here, I have 1 over 2 x raised to the 1.5 plus 0.25, right? And if I write this, my final answer would be 1 by 2x raised to the 1.75. And yeah, that will be my final answer. For the example, we again have a lot of powers, and it's not only given in the form of x, but we have root x. That means we have a lot of powers to simplify at this point. So what I can do is I'll first focus on this one term and see how can I, write this as a singular power. So one thing that I want you to remember is that root of anything, like if it's the square root of a term, then that basically means that that term is raised to the power of 1 by 2. If it's a cubic root of something, it is raised to the power of 1 by 3. Right? I mean, this is something that we just learned, but I want you to remember these two cases because these are the cases you'll be asked most frequently. So that means root x becomes x raised to 1 by 2. And as you can see that root x is then raised to the 3rd power. That means what I have is that x raised to 1 by 2, that's the same as root x. This whole thing is then raised to the cube, right? So that means this then becomes x raised to 3 over 2 from our first video. Right here we have a power with a term already, and then we'll again have a power outside the bracket. So what we do is that we just multiply these 2 powers together. So that was the first term. What about the second one? Now again, here again in this one you can see I have a cube root, right? Like I said, this can be written as x raised to 1 by 3. And again, whole of that is raised to the 4th power. That means I can simplify this by writing x raised to the power of 4 by 3, right? And again, from our first video, if you have 2 terms which you're trying to multiply together, but they have the same basis, but they have different powers, what we do is that we just add their powers, right? So I'll write x over here, and then I have 3 by 2 plus 4 by 3. So I'll take a minute and I'll put that into my calculator and see what we get. So we have 3 by 2 plus 4 by 3, and that gives me x raised to the 17 over 6, and this will be the final answer. For the last example that I have over here, now again, this is very similar to the previous example that we just did, except for the fact that it looks way more terrifying. So what I'll do is that firstly I'll just write it in a better form. I'll write x raised to 1, because this has got nothing else, times 2x raised to the minus 1/3, whole of that raised to the 4th power. Now I'll just put this x raised to the 1st power aside, and we'll work over here. Now instead of going and taking the reciprocal of 2x and then assigning it the power of 1/3, what I'll do is first I'll just like simplify these two together. So I'll write 2x, and for the power what I'll do is I will multiply minus 1/3 into 4, right? And if you don't know why, I suggest you can go back and watch the first video in the series, because that's where I've explained the basic laws of indices. But yeah, then we have 2x raised to the minus 4 by 3. Okay, now again I've got the same variable, but I have different powers. So how can I write that? So I'll take 2x raised to, and then because we have multiplication, I am going to add these two powers. So then I have 1 plus minus 4 by 3. If I can simplify that further, I get 2x raised to the 1 minus 4 by 3, and if I take my calculator again, 1 minus 4 by 3, I get 2x raised to the minus 1/3, right? So if you also want to simplify this further, what you can do is, I mean, you can also leave your answer over here, but again, if you want to go ahead and do it fully, you can take this 2x raised to minus 1/3. Again, if something means minus, we're basically talking about reciprocals. And again, because we have a denominator over here, we know that it has something to do with the root, so that becomes 1 over the cube root of 2x. So yeah, that's the original term, and that's the final answer.